Welcome to this premium level preparation video on microservices interview questions for junior developers. In this video, we'll cover 50 essential questions explained in a simple, beginner-friendly way. This is the perfect resource for quick revision, building strong fundamentals, and acing your interviews. Let's dive in and get you fully prepared. So question number 1 is, what are microservices? Microservices are an architectural style where an application is built as a collection of small, independent services. Each service does one job and communicates with others using APIs. For example, in an online shopping app, user service handles login, order service handles orders, and payment service handles payments. Each service runs independently and can be updated or scaled without affecting others. Now, let's move to second question. How is monolithic architecture different from microservices? In a monolithic architecture, the entire application is built as one single unit. All features are tightly coupled, so even a small change requires redeploying the whole app. Whereas in microservices, the application is split into multiple small services. Each service works independently and can be developed, deployed, and scaled on its own. Question number 3 is, why do companies use microservices? Companies use microservices because they make applications easy to scale, allowing only the required services to grow. They also enable faster development, since teams can work on different services at the same time. Another big reason is independent teams. Each team can own and deploy their service without waiting on others. Plus, microservices offer better fault isolation, meaning if one service fails, the entire system doesn't go down. Next question. What is an API in microservices? An API is the communication method that allows microservices to talk to each other. Most commonly, this communication happens using HTTP and REST. The data is usually exchanged in JSON format, and the API acts like a contract between services, defining what data can be sent and received, so each service knows exactly how to interact with the other. Question number 5 is, what is REST? REST stands for Representational State Transfer, and it's an architectural style used for building APIs. It uses standard HTTP methods like GET, POST, PUT, and DELETE. REST is stateless, meaning each request contains all the information needed, and it works with resource-based URLs like users or orders. Next question number 6, what are HTTP methods? HTTP methods define what action we want to perform on the server data. GET is used to read data or fetch data. POST is used to create new data, PUT to update existing data, and DELETE to remove or delete data. So basically, each HTTP method has a specific purpose and tells the server exactly what operation to perform. Let's look at the next question. What is statelessness? Statelessness means the server does not store any client state. Each request is independent and contains all the information needed to process it. Because the server doesn't remember previous requests, it improves scalability, making it easier to handle more users. Question number 8. What is service-to-service communication? Service-to-service communication is how microservices talk to each other. They usually use APIs, either over HTTP or messaging systems. This communication can be synchronous, where one service waits for a response, or asynchronous, where they don't wait and continue working independently. This is a commonly asked question. What is synchronous communication? Synchronous communication is when a service waits for an immediate response from another service. It's usually HTTP-based and is a blocking call, meaning the first service can't continue until it gets the reply. This is also a commonly asked question. What is asynchronous communication? Asynchronous communication is non-blocking, meaning a service can continue working without waiting for a response. It often uses message queues and provides better performance and scalability for microservices. Now here's a bonus question. What if interviewer asks to compare synchronous and asynchronous communication and asks a follow-up like, which one is better and why? So you can answer it this way. In synchronous communication, a service waits for an immediate response. It is usually HTTP-based and blocking, which means the service cannot continue until it receives a reply. For example, an order service calls a payment service and waits for the payment result before confirming the order. In asynchronous communication, a service sends a message and continues processing without waiting for a response. It is non-blocking and commonly uses message queues. For example, an order service publishes an order event to a queue, and the notification service processes it later to send an email or SMS. Now let's discuss which one is better and why. There is no single best option to choose, because it's scenario-based. Synchronous communication is better for real-time, request response use cases. Asynchronous communication is better for scalable, resilient systems where services should not depend on immediate responses. Now question number 11 is, what is a message queue? A message queue is a temporary storage system that holds messages until they're processed by the receiving service. It helps decouple services, meaning services can communicate without directly depending on each other. This improves reliability because if a service is down, messages can still be stored in the queue and processed later. It's a key component in microservices architectures for ensuring smooth, reliable communication. Okay, the next question is, what is a database per service? In a database per service pattern, each microservice owns and manages its own data. There is no shared database between services. This provides better isolation, so changes in one service's data or schema don't impact others. It also improves scalability and makes services more independent, something interviewers often look for in microservices design. Next question is important and interesting, and that is, can microservices use different technologies? Yes, absolutely. One of the key benefits of microservices is technology flexibility. Each service can be built using different programming languages and can use different databases, depending on what fits best. This allows teams to choose the right tool for each job, which is a common advantage discussed in microservices interviews. For example, a login service is built using Java, while a product service is built using Python. Each service uses the technology that best fits its functionality. This is a commonly asked question: what is scalability? Scalability is the ability of a system to handle more users or increased load. In microservices, this is achieved by scaling individual services instead of the entire application. This makes the system more efficient and cost-effective, and it's a key concept interviewers expect you to understand. Here's another commonly asked question: what is horizontal scaling? Horizontal scaling means handling more load by adding more instances of a service instead of increasing its size. This approach is very common in microservices, as it allows services to scale independently and improves availability. For example, if a login service is getting too many user requests, instead of upgrading one server, you run multiple instances of the login service behind a load balancer. This way, traffic is shared and performance improves. Next one, what is service discovery? Service discovery is the process of finding the locations of services in a system. It's especially important in dynamic environments like microservices, where services often change their network addresses due to scaling or failures. Service discovery helps services communicate reliably without hard-coding addresses. Another important question is, what is an API gateway? So an API gateway acts as a single entry point for all client requests to your microservices. It routes requests to the right service and also handles security tasks like authentication and rate limiting. It simplifies communication and protects your backend services. Interviewer can also ask another similar question: why use an API gateway? We use an API gateway for centralized security, so authentication and authorization are handled in one place. It also manages request routing to different services and provides a simplified interface for clients, making the system easier to maintain and secure. Here's another easy and commonly asked question: what is authentication? Authentication is the process of verifying a user's identity. It's what happens during the login process when you prove who you are, usually by entering a username and password. Another easy and common question you will be facing in interview is that what is authorization? Authorization is about access control, deciding what actions or resources a user is allowed to access. This is often managed using role-based access, where permissions are assigned based on user roles. A quick tip that will help if interviewer directly asks you the difference between authentication and authorization. So an authentication is about verifying who you are, while authorization is about what you are allowed to do. In simple terms, logging in checks your identity, and permissions decide what you can access after logging in. Here's a very common interview question: what is JWT? This is a frequently asked question, so it's important to be clear on this. JWT stands for JSON Web Token. It's a compact token format used for authentication and authorization. Once a user logs in, the server issues a token, and that token is sent with every request to prove the user's identity. One key thing to know is that JWT is stateless. This means the server doesn't store session data. All the user information and validation details are contained inside the token itself. For example, after logging in, the client sends the JWT in the request header, and the server validates it without checking any session store. Next question is, what is fault tolerance? Fault tolerance means the ability of a system to handle failures and still continue running. Even if one component fails, the overall system keeps working without impacting users. For example, if one service instance goes down, traffic can be automatically routed to another healthy instance, so the system remains available. Next question, what is a circuit breaker? A circuit breaker is a pattern used to prevent cascading failures in a system. When a service keeps failing, the circuit breaker stops repeated calls to that service for a period of time. For example, if service A keeps calling service B and B is down, the circuit breaker opens and blocks further calls, allowing the system to recover instead of getting overloaded. Next is a simple question, what is logging? Logging is the process of tracking events and actions that happen inside an application. It helps teams debug issues, monitor behavior, and understand what went wrong when something fails. For example, error logs can show why a request failed, while info logs can help trace how a request moved through the system. Next question, what is monitoring? Monitoring is about tracking system performance and detecting issues early. It involves collecting metrics like response time, error rates, and resource usage to ensure everything is running smoothly. For example, if response times suddenly increase, monitoring tools can alert the team before users are heavily impacted. Next question, what is deployment? Deployment is the process of releasing a service to the production environment so users can start using it. It typically involves moving code from testing or staging into production in a controlled and reliable way. For example, a new version of a service can be deployed using rolling or blue-green strategies to avoid downtime. Here's a frequently asked interview question. What is CI/CD? CI/CD stands for Continuous Integration and Continuous Deployment. Continuous integration means developers regularly merge code into a shared repository, with automated tests ensuring nothing breaks. Continuous deployment means the code is automatically released to production after passing tests, making updates faster and more reliable. For example, every time a developer pushes a change, the CI/CD pipeline runs tests and deploys the update if everything passes. Here's another important interview question. What is containerization? Containerization is the process of packaging an application along with all its dependencies so it can run reliably across different environments. It ensures consistent environments from development to production, avoiding the "it works on my machine" problem. For example, Docker allows you to containerize an app so it runs the same way on your laptop, staging, and production servers. Next, another commonly asked interview question. What is Docker? Docker is a platform for running containers, allowing you to package applications with all their dependencies. It's lightweight, fast, and ensures that your app runs the same way in any environment. For example, a web service can be packaged in a Docker container and run on a developer's laptop, a test server, or in production without any changes. Next question is also an important one. What is Kubernetes? Kubernetes is a container orchestration platform that manages scaling, deployment, and operation of containerized applications. It ensures containers run reliably, distributes workloads, and can automatically scale services based on demand. For example, if traffic spikes, Kubernetes can spin up additional container instances to handle the load and then scale down when traffic decreases. Question number 31. What is configuration management? Configuration management is the practice of keeping application settings externalized and managing them based on environments like development, staging, or production. This allows the same code to run in different environments with different settings without changes to the code itself. For example, database URLs or API keys can be stored in external configuration files or services, so the app picks the right settings depending on where it's running. Here's a commonly asked interview question. What is versioning in APIs? API versioning is the practice of labeling APIs as V1, V2, etc. to manage changes without breaking existing clients. It ensures backward compatibility, so older applications can continue working while new features are added. For example, if you update an endpoint to include new data, you might release it as /API/v2/users while keeping /API/v1/users available for existing clients. Here's another important and frequently asked interview question. What is load balancing? Load balancing is the process of distributing incoming traffic across multiple servers or instances to improve availability and performance. It prevents any single server from getting overloaded and helps ensure the system remains responsive. For example, a load balancer can route requests between 3 service instances, so if one goes down, the others continue handling traffic. Question number 34. What is high availability? High availability means designing a system to have minimal downtime by using multiple instances or redundant components. If one instance fails, others take over, keeping the service running smoothly. For example, running 3 instances of a service across different servers ensures that even if one server goes down, users don't experience interruptions. Question number 35. What is a timeout? A timeout is the maximum time a system or service will wait for a response before giving up. It helps avoid hanging calls that could block resources or slow down the system. For example, if service A calls service B and doesn't get a response in 5 seconds, the call times out, and service A can handle the failure gracefully. Next question, what is a retry mechanism? A retry mechanism reattempts failed calls to a service, usually with limited attempts to prevent endless retries. It helps improve reliability without overloading the system. For example, if a request to a payment service fails, the system might retry up to 3 times before marking it as failed. Question number 37. What is idempotency? Idempotency means that repeating the same operation produces the same result without unintended side effects. It ensures consistency even if a request is accidentally sent multiple times. For example, if you call a create order API with an idempotent key twice, it will only create 1 order instead of 2. Next question, what is data consistency? Data consistency means keeping the correct and expected state of data across services. It ensures that all parts of a system reflect the same information at any given time. For example, if a user updates their profile, data consistency ensures that the updated name appears correctly in the user service, billing service, and notification service. Question number 39. What is event-driven architecture? Event-driven architecture is a pattern where events trigger actions in different parts of a system, promoting loose coupling between components. Services don't call each other directly. Instead, they react to events as they happen. For example, when a user places an order placed event can trigger inventory updates, payment processing, and email notifications independently. Here's an important and frequently asked question. What is loose coupling? Loose coupling means designing services or components to be independent, so changes in one don't heavily impact others. It makes the system more flexible and easier to maintain. For example, if the payment service changes its internal logic, the order service can continue working without modification because they communicate through well-defined interfaces or events. Okay, next question is, what is tight coupling? Tight coupling means there's a strong dependency between components or services, making the system hard to change. Changes in one service often require changes in others, which increases complexity and risk. For example, if the order service directly depends on the payment service's internal logic, updating the payment service could break the order service. Next, we have a bonus question section. What if interviewer asked the difference between loose and tight coupling? So loose coupling reduces dependencies between components, making systems easier to maintain and scale. Tight coupling creates strong dependencies, which can simplify small systems but makes large systems harder to change. If interviewer pushes further and asks which one is better and why, then you can answer this question like, in general, loose coupling is preferred because it promotes flexibility, scalability, and maintainability. With loose coupling, each component or service is isolated, making it easier to modify or replace parts of the system without breaking everything else. It also allows for better fault tolerance and easier integration with new technologies. However, there are situations where tight coupling might be appropriate, especially when components need to work together closely and the performance or coordination overhead of managing loose coupling is not justified. So, while loose coupling is generally the best practice, tight coupling can still have its place depending on the specific requirements of the system. Next interviewer can also ask, when is tight coupling actually okay? Tight coupling can be acceptable in situations where performance or simplicity is a priority and the system is small or not expected to scale or change frequently. For example, in a monolithic application, tight coupling between components might be acceptable because all parts of the system are tightly integrated and changes are easier to manage within the context of the whole system. Additionally, tight coupling might be acceptable when you're working with a small team or a highly specialized system where the services must operate in a very coordinated way and flexibility isn't as critical. However, as the system grows or evolves, it's typically recommended to move towards more loosely coupled architectures to accommodate changes in scaling. Let's move to next question. What is a health check? A health check is a way to check the status of a service to ensure it's running properly. Monitoring tools often use it, and it's usually a simple endpoint like /health that returns the service's current state. For example, a load balancer can call /health to decide whether to send traffic to a service instance. Next question. What is blue-green deployment? Blue-green deployment uses two environments, blue and green, to release new versions of a service. It allows zero or minimal downtime and makes rollback easy if something goes wrong. For example, the green environment runs the new version while blue handles production traffic. Once verified, traffic is switched to green seamlessly. Next question is, what is Canary deployment? Canary deployment is a strategy where a new version of a service is released to a small user group first, allowing a gradual rollout. It helps reduce risk by catching issues early before affecting all users. For example, 5% of users might get the new version initially, and if everything works fine, the release is expanded to 100% of users. Here is an important question. How is security handled in microservices? Security is handled through authentication, authorization, and secure communication between services. Authentication verifies who a user or service is. Authorization controls what they can access, and secure communication, like using HTTPS or encryption, protects data in transit. For example, a service may use JWT tokens for authentication and TLS for encrypting data between services. Here's another important and frequently asked interview question. What is HTTPS? HTTPS is a protocol that provides encrypted communication between clients and servers. It protects sensitive data like passwords or payment information and is much more secure than HTTP. For example, when you log into a website, HTTPS ensures that your credentials are encrypted and safe from eavesdroppers. Next question, what is rate limiting? Rate limiting limits the number of requests a client can make in a given time period. It prevents abuse and helps improve system stability by avoiding overload. For example, an API might allow a maximum of 100 requests per minute per user. If a client exceeds that, further requests are rejected until the limit resets. Here's the next question. What is a microservice boundary? A service boundary defines a clear responsibility for a service, focusing on a specific business function and ensuring logic doesn't overlap with other services. It helps keep the system modular and easier to maintain. For example, an order service handles only order-related logic, while a payment service manages payments separately. Second last question, what are the challenges of using microservices? Some challenges include increased system complexity, network communication issues, and harder debugging compared to a monolithic system. Managing multiple services requires careful coordination, monitoring, and handling failures gracefully. For example, tracing a request that passes through several services can be tricky without proper logging and distributed tracing tools. Now the last question, when should you use microservices? Microservices are ideal for large applications, when there are multiple development teams, or when there's a need for scalability. They allow independent development, deployment, and scaling of different parts of the system. For example, an e-commerce platform can have separate services for orders, payments, and inventory, each managed by different teams and scaled independently. That's a wrap on our microservices interview preparation. If you found this helpful, don't forget to like, subscribe, and hit that bell for more interview tips. Got questions or thoughts? Drop a comment below, let's chat. And if you know someone who's prepping for interviews, share this video with them. Thanks for watching, and good luck with your interview. Go crush it.